Welcome, my name is Brian Nelson. This is my first video that isn't related to a course. My goal is to produce a mix of videos related to courses and other topics relevant to programmers. To that end, Microsoft recently released version 9 of the C# programming language, and I wanted to take a look at its new features. To use the new C# 9 features, you will need to make sure that your Visual Studio is up to date. On Windows, you will need at least version 16.8 of Visual Studio. You will also need to install .NET 5. With .NET 5, Microsoft is beginning to unify the .NET framework and the .NET Core libraries. There are three primary new features that I wanted to review in C# 9. The first feature is records. Records allow for the quick definition of immutable reference types. When you define a record, the compiler will create several useful pieces of functionality for you. These include methods for value-based equality comparisons, an override to the getHashCode method, copy and clone methods, and an override to the toString method. Let's take a look at records in Visual Studio. I'm going to create a new console app. I'm going to create a .NET Core one. Now, the first thing you need to check is what version of Visual Studio you have. And you can tell that right here. I've got 16.8.4, and I believe you need a version greater than 16.8. So if you don't have that already, you'll need to upgrade to the latest, and you can use the Visual Studio installer to do that. Now, the next thing you're going to need to do, now I'm going to save that, and let's go down here, and C# 5.0 core install. So that's the next thing you're going to need to do is get C# 5, and you can do that right here. .NET, and basically it's easiest just to search for it, but you're going to find the Microsoft site, download .NET 5. Let's choose for Windows x64. That's what I'm using. You can pick whatever you need. Okay, once it's downloaded, we can open it. Okay, so I'm going to go ahead and install it. Okay, so that's done. So let's go back to our project now. And we can now click on, let's click on the project. And rather than .NET Core, we're going to pick .NET 5.0. Now, .NET 5.0, they have dropped the .NET Core naming. It kind of unified all of the language, and they've skipped .NET Core 4.0 to avoid the confusion of the .NET Framework 4.x that was out there previously. From now on, it'll be .NET 5 until, the next versions come out. So anyway, I've picked .NET 5. That will let us use the C# 9 functionality. Okay, the first thing we're going to look at is records. So I'm going to create a folder here, add new folder, record. That's just for organization. I'm going to create a add class, and I'm going to say person. Okay, but rather than class, we're going to say record. So we're going to make it a public record. So what a record does is it allows you to define immutable reference type objects. Immutable means they cannot be changed. Reference type means that they are passed by reference. You hold a pointer to that object and you can pass it around. So that's the basic definition. But what records do is allow us to do a lot of shortcut coding practices, and they generate a lot of the code behind the scenes, and we never have to really deal with it. In the class definition, we can then say something like and I'm going to actually, that's how I would define it with a lowercase g, kind of a lower camel case, but I'm going to do an upper camel case because what happens is it will generate two properties, read-only properties, that with the uppercase names. So let's go test this in our program. So we can now define person person1 equals new person. And let's add a using. All right, and so it's going to take 2. So what we can say is something like John Edwards. I'm going to go ahead and duplicate this. Family name, fine. Let's go ahead and run this, and I'm going to put a breakpoint at line 15 and F5. It looks like any other class as far as being able to read from the class. We didn't have to define the family name. By declaring this as a record, it generated the family name and the given name properties. And so we can see console.writeLine person1 given name. So both of those just appeared there. Now, the next thing that's neat about records is we can use some built-in equality checking. So if person1 equals person2, and you notice they both have the same first and last name, console.writeLine, we'll say they match. And let's just put a breakpoint here and hit F5. Without having to do any equality overrides or overloading, we were able to just test those two records. The next thing that's neat about records is the toString operator is automatically overwritten. So we can do console.writeLine person1. Let's go ahead and run to the end. So we should get, they match. And then if we look at the output, we get the type of record, which is person, and then the given name and family name in a quasi JSON format. So that is automatically generated. Say we want to create a full name property. We can do that just like we would with any other object. Public if we go back over, we can just say, instead of printing the whole object, we can do full name and print that. And F10. So now if we look at our output, it prints that out. Since this is generated, I just wanted to show person1.familyName equals test. It's not going to let us do that. These are read-only. That's the whole point. It only initializes it. This is not allowed. I'm going to move. What I've set up here is a little static function in the program class to just test if the two person objects match. Rather than do this, I can just say test equality person1 comma person2. And so now that will print that out. So that's great. And I'm going to get rid of that. Now let's create a new person. We can test equality person 1, comma, person 3. And let's run that. And if we look, the first person did match and the second does not. So that makes sense. Now what I want to do is, let's create a person helper object. I'm going to create a new folder. And I'm going to make that static. I'm going to create a helper routine to marry two people. So we'll do public static person marry. And we're going to have this. It's going to be an extension method, person. And I do need let me add the using so it will stop bothering me. All right, so now it's happy. And we'll call it person A, and then person B. And then I'm going to have a bool take new family name. So person output. And so if take new family name, the next neat thing with records is the ability to do a with statement. Now, since the person object is a record, we can't change it. It's immutable. So we need to define a new one and assign it the new family name. So one approach we could just do is say output equals new person, and we're going to take person A's given name and then assign person B dot family name. So person A is taking person B's family name. Now there's a new approach to doing this, which is to use the with operator. Output equals person A with family name equals person B dot family name. What this does is it's going to create a new record and assign the family name from person B. So we can now do that. Now, otherwise, if they're not taking the family name, we can say output equals person A with, since it's immutable, we're just returning a clone of person A. No values have changed, whereas with the take new family name to be true, we're going to reassign the family name from person B. And then the final thing we need to do here is return output. All right, and then let's go back to our program. Let's define person 4 equal new person. And we'll say John Smith. And we need to add a using. So let's add our using. I'm going to move that up here, records. So we've added our helper. Person 3 equal person 3 dot marry. And we're going to say person 4. And let's try it with take new family name. And we'll just say true. And let's print out, let's just do that, console dot write line. And let's run that. Okay, so if we look at our output, Mary Smith. So we did take the family name. Now, if we've decided we don't want to take the family name, we can just say false, and we can look at our output, and we get a new object with Mary Edwards, the other thing you can do with records is you can do inheritance. So let's go ahead and add a new class, and we'll call it employee. And instead of a class, we're going to do public record. And we're going to say int employee number, string given name, string family name. Now we have a new record, employee, and it extends person. So it should now have an employee number, a given name, and a family name. So let's go back here and let's create an employee. And a number of 1, and we'll just do John again, Smith. And then what we can see here, though, is if we say if employee 1 equals person 4, and let's go ahead and say console.writeLine, employees do not match person object records. Okay, let's put a breakpoint there. And this is just a test. We're comparing an employee record with a person record, and let's see what happens. So we did not hit that, so they are not equal. So employee 1 does not equal person 4. The second new feature in C# 9 that I want to review is init-only setters. Init-only setters allow the programmer to restrict setting property values on an object to during the initialization period of that object. Prior to C# 9, a programmer would have to create one or more constructors for this purpose. Let's take a look at init-only setters in Visual Studio. Okay, let's now look at init-only setters. And I'm going to create a new folder called objects. And I'm going to create a simple object, and we're just going to call it class, and we're going to call it room, like office rooms, and public. And then it's going to be public int number. And we're going to say get and init. Now, what this will let us do is only during initialization can we set the room number. Let's add our using. Let's set up our room. And we're going to use an initializer, and we're going to say number equals 500. And there we go. Okay, and so what we can now see is room.number equals 512 is not allowed. So this is not allowed due to init only. This is a simplification to let us set it up with an initializer rather than creating a constructor that would pass in the room number and then make it a private setter. This lets us do that very quickly. So I'm going to comment this out because that won't work. Now I'm going to also set up a new object. And I'm going to make it public. And we'll just do public string street 1, public string street 2, Okay, so we've got that simple little object set up for recording addresses. I want to show one other new thing with constructing objects. We can do address. That's the typical way. And then we can say now we can now do a shortcut like that. And that these are equivalent statements. We can also use the new function with an initialization as well. Those are new shortcuts that we can now take to make our code a little cleaner. So one thing to note here is that we can't use var address 3 equal new. It just doesn't know what to create new. So you either can use the new with an explicit definition, or you can use var, kind of an implicit with an explicit instantiation. We will just comment that out. Can't do both. The final thing I wanted to introduce is pattern matching. Pattern matching is a new rich syntax that allows for the definition of comparisons with a more English-like syntax. My examples just touch on the surface of its capabilities. I recommend that you investigate this topic more if you're interested. Let's take a quick look at some of the pattern matching capabilities in Visual Studio. We're going to go back to our room number. So we've got a room object defined with number equal 500. So what we can do with pattern matching is make it a little more English. So what we can say is room.number is greater than or equal to 500 and less than 600. We say console.writeLine 5th floor. Else if room.number is greater than equal to 600 and I missed the is, and less than 700, console.writeLine. So this gives us a little more English kind of grammar to simplify the reading of the code. It still was functionally, I mean, you could obviously still do this the old way. It just required a little more. This is pattern matching approach. So let's look at the old way of writing that. If room.number is greater than or equal to 500, and room.number is less than 600. Okay, so that's the old way. So the pattern matching approach is just easier to read. It does functionally the exact same thing under the covers. So I'm going to go ahead and comment this out. You can also use pattern matching for null checking. Okay, so you can do something like that to check is not null instead of the old approach would be if room2 not equal null. So both of those do the exact same thing, and I'll go ahead and comment this out, or let me say. The examples here were a quick review of what I thought was most interesting in C#9. I've included a link to Microsoft's post on all of the new C#9 features in the description below. I hope you found this video useful. Please subscribe to the channel so that you can get future updates like this one. Thank you.